Okay, let us discuss this question, problem number 1.7. This question is more mathematics, less physics. So you have problem 1.7. So in this question there is very little physics, almost null. So let me first make the diagram. So we have a diagram. They call this point as A, and there is a point C. This point they call him D, and there is a, so this goes, and there is a distance L, and there is a connected through this, and they are calling this point as a B. Now let me read the question. So from point A, located on a highway, so this is a highway, so basically road you can say, so on this road some car can go. So from A, located on a highway, so point A is basically located on the highway. One has to get by car as soon as possible to point B. So if somebody wants to go from point A to point B using the car. And this question says, it is known that car moves in the field. So this is the field. So these are field. This is a highway. This is the field. It is known that car moves in the field eta times slower than on the highway. So on the highway, let us say this moves with velocity v. So this side, this moves with a velocity eta times slower than the velocity on highway. So what will be the velocity in the field? So velocity on the highway is v. So this is velocity on highway. Velocity on highway is v. So what is the velocity in the field? And question says velocity in the field is eta times slower than the velocity on the highway. So what is the velocity on the field? Basically if I say eta is less than 1, eta is less than 1, so eta times v, that is the velocity in the field. Eta is basically less than 1. This is not given in the problem then, but we can assume that eta is less than 1. Now we have to find, so question says at what distance from point D one should turn off the highway. So if you want to go from here to here, you have many routes. Either you can go from here to point D or you can come to B. So this is one option. Another option you can go some distance on the highway and then take a turn and then go to the B. And this C is basically variable. Either you can take a turn from here, either you can take a turn from here, either you can take a turn from here. So this C is basically variable point. So C is variable. You can vary the C, and if you vary the C, basically time will be different. So question asks, what is the distance of C from D, so that time to reach from here to here is minimum. So I want time, minimum time. Are you getting? Now this is fairly easy problem. So what you will have? What is the time required? So this distance, total distance, is not given or given in the problem. So let us say, let me see, just wait for 1 minute. So let us say this distance is L0. So this distance, let us say, is given in the problem. So from A to D, this distance is L0. So this distance is L0 minus x. So what is the time from A to C? So time from A to C will be, distance is L0 minus x and velocity is v. Are you getting? From C to B, if this follow this path from C to B, what will be the time? This distance, that is L square plus x square under root, L is given, L square plus x square under root, this is the distance, divided by velocity eta times v. Now what is the total time? So this plus this. So total time is, so I can write total time is basically L0 minus x by v plus under root L square plus x square eta times v. Now basically this t is a function of x. So I'd have to minimize the time. So t will be minimum when dt by dx is 0, because time is a function of x. So this is, if you differentiate this one, so this is constant 0. So this is minus 1 by v. So here you will have minus 1 by v. Are you getting? And now here you will have, so differentiation of this is root x is 1 by 2 root x L square plus x square. And then you have to differentiate x square also. So differentiation of x square is 2x, and in the denominator you have constant eta times v, and this is equals to 0. If you put this is equals to 0, so you will have 1 by v is equals to 2x divided by 2x L square plus x square eta times v. Now let us say what are the things that you can cancel. 2 cancel. Oh, basically there is no x in the denominator, you see here, no x. So you will have this. V also you can cancel. So you will have this eta times under root L square plus x square is equals to x. So you square both sides. So you will have eta square L square plus x square eta square is equals to x square. So if you solve for x, so you take this x square this side, so you will have eta square L square. Take x square common, 1 minus eta square. This is the, so now you can solve for x. So if you solve for x, you will have x square is equals to eta square L square divided by 1 minus eta square. So if you take root, you will have x is equals to eta L divided by root over 1 minus eta square, and eta square is basically eta is less than 1, so eta square is also less than 1. So in the denominator we have a positive number, so root is defined. See, basically what we are result we are getting, we have to check also whether root is defined or not. So you can clearly see this is root is defined. So this is the distance after which this object should take a turn. Are you getting or not? So you see, basically in this question the top is, you see this distance, that should be eta L divided by 1 minus eta square. So this is the distance after which this has to take a turn. So this is the velocity. Now if you see the answer is given in your book, that is x is equals to L by 1 minus eta square minus 1. So basically they have taken something like different. So they have taken, so I have said velocity on highway is v and velocity on the field is eta v. So they have taken this divided by eta. So velocity on the highway is v, so they have taken eta is greater than 1. In that case you will have velocity on the highway is v. So velocity on highway is v. So they have taken eta is greater than 1. So velocity on highway is v, and velocity on field they have considered v by eta. Are you getting? So if you consider v by eta, every place you will get the same thing. Only thing is, so you can verify the same thing, so you can get the same answer. In that case, if you follow that notation, in this case eta is basically greater than 1. So you see, what will the changes you will have? You will have TAC, that is v, but TCV, that is v by eta. So I can also follow the same thing. So total time will be L minus x. I can solve for you so that you can verify yourself you are getting the same answer that is in the book. Plus L square plus x square divided by v by eta. Because velocity in the book they have considered eta as greater than 1, so v by eta. Now I can differentiate L minus x by v plus eta times L square plus x square divided by v, and this I have to differentiate. So if you differentiate dt by dx, so let us say differentiate and put it 0, and then you will get the desired result. Are you getting? So you have to apply this condition. So this is the total time. So dt by dx, if you apply this condition, so let me do for you. So dt by dx, this is equals to minus 1 by v, and this eta remains. So you will have 2x on the top and root over 2 root over L square plus x square. Here you will have v also. This is equals to 0, so v goes out, 2 goes out, so you will have L square plus x square is equals to eta square x square. Are you getting? So if you take x, so this will come out to be L divided by root over eta square minus 1, and that is the answer that is given in the book. So you see, if eta is, so question does not say something about eta. If eta is greater than 1, then I have to take, question says velocity in the field is lesser than the velocity on the highway. If the velocity on the field is v, on the highway is v, then velocity in the field is v by eta if eta is greater than 1. But I have taken initially, what I have done is, velocity on the highway is v, velocity in the field is eta times v, because I have considered eta is less than 1. Question does not say anything about eta. So question gives me the answer is this. This means I have to assume that eta is greater than 1. So velocity in the highway is v. So velocity in the field that is lesser and eta is greater than 1, then in that case I have to divide the velocity. So this is v by eta. And then I have to find total time. So distance on the highway is L minus x. This divided by velocity on highway. Distance on field is this L square plus x square under root. And velocity on the field is v by eta. Now if I differentiate this time, I will get x is equals to and L by under root eta square minus 1. In this case you can also verify this root is defined because eta is greater than 1. So basically you see I have solved this problem using two conditions, if eta is less than 1 and eta is greater than 1, because the question is slightly ambiguous. We does not know eta is greater than 1 or eta is less than 1. So if eta is less than 1, in that case I have to assume the velocity in the field is eta times v. If eta is greater than 1, then velocity in the field is v by eta. In both cases, velocity in the field should be lesser than the velocity on the highway. Everybody knows. If you have a car and you want to go with a car on a highway, you will have a higher velocity, and if you go on with the same car in the field, you will have a lesser velocity, because field have some resistance forces that is acting there. Okay, let us copy this one and then we're going to go for the next problem. This is easy problem basically. Okay, let us discuss the next problem.